He's going to really, 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 really prove it's flat this time.
And the table being flat gives us a perfectly straight baseline.
I cannot quite believe my ears. Dave's just put it flat. You know, made it really clear that 90 meets a flat surface. Right, Dave?
As to why it doesn't work on a globe. In order to do trigonometry, you need a triangle, and triangles have flat sides. And obviously the globe doesn't. It becomes even simpler if you're already dealing with a right angle straight out of the gate.
Because you'll have already proven a flat Earth at that point. I don't seem to see any assertion of height on here. Where does it show you the height? Oh, it doesn't. Oh, it's because it's not relevant, Dave, you stupid straw-manning idiot.
From the Smithsonian Magazine.
You want to read it out? Go ahead.
A sextant is used to measure the altitude of a celestial body above a horizontal line of reference. Altitude, in this case, is a special use of the word describing an angular measure, not distance in feet above sea level. Not distance in feet above sea level. Describing an angular measure, not distance in feet above sea level.
He's going to try and strawman us with this. You need a height, something that celestial navigation never ever use or claim to the celestial body. Is take the angular measurement that he on the flat Earth he needs to take it, right, and then put it at the center of his globe and make the distance an arc length.
Once he's acquired the angles from a flat Earth, he'll then utilise them with his sphere belief after measuring them off a flat Earth. I see.
Yeah, it's a bit more scummy though. What he's trying to do is hijack the actual reality, which is the measurements of a flat Earth.
Angle measurements, which is what we do in celestial navigation. We take angle measurements, and they're done with reference to a baseline. This requires a flat Earth. So long as we're all clear from this point forth that the only way we can acquire these angles are if this line is straight, that requires a flat Earth. I just want to say this one more time for any of Dave's audience that may be watching. This is me responding to Dave's claims as opposed to hand waving them. He is in fact a liar because we are responding and using his own words to prove angle measurements as described in his comments, because I don't need any of this, I've already got it from him, require a flat baseline. Now this guy measuring a star over here could be 5,000 miles away from this guy, but they're both measuring with respect to the same baseline, flat Earth.
You can then calculate where those angles will intersect.
So long as you've got a flat Earth to get the angles from.
And create a triangle.
So long as Earth is flat and the baseline is flat.
You can subsequently calculate the height above the baseline where those lines intersect.
Do you want to show us where that's done in celestial navigation? Because that's what was being detailed in Wandek's comment to you. So, given that celestial navigation with triangles is on your thumbnail, I'm going to assert that this is a straw man. Again, because this isn't in reference to celestial navigation. Your thumbnail shows triangles on a pizza pie Earth straw man. Yet another straw man I don't claim. This video is about me, I don't claim this. Meanwhile, you've got triangles on this surface. They don't seem to be all referencing a point for triangulation, which kind of tells me that you don't understand how this process works, or you'd have depicted it in a better way. You don't. That much is clear. You don't even know what latitude is. However, you are still asking us about a height, which isn't necessary in celestial navigation, which is what this discussion's about. Strawman.
Which forms two right-angled triangles.
Yeah, you need a flat Earth for those right-angled triangles. Okay, so at this point, Dave is continually and perpetually proving a flat Earth. Because to do this, acquire this, which is step one, this is the representation of the ground, and it's flat. So we need 90 degrees, Dave. You're doing a wonderful job. And we need a flat baseline to measure these angles. So long as there's angle measurements involved, it's going to be referenced to the flat Earth. Okay, moving forward, I just want the audience to cement that in their mind. If there are any references to baselines, 90s, or angle measurements, it is always and can only be in reference to measurements taken from a flat surface. Facts. That's what angles are. They're not meeting curves.
It becomes even simpler if you're already dealing with a right angle straight out of the gate.
Why? Because you've already measured it off a flat earth at that point, Dave. So if you start with the angle that's only acquirable from a flat earth, it's much easier. Yeah, you sound like Protothad and MC Toon. Yeah, they both had the same problem. See, MC Toon offered up a £10,000 challenge for how we could use only acquirable flat earth elevation angle measurements on a flat earth. And we pointed out to him, I pointed out personally to Toon, in excess of 86 times. It's another one of those fake laughs. The 86 renditions that you could only get the measurement off a flat earth, Dave. Do you want me to show you? Here it is, it's your example. Here's an angle measurement. It requires a flat baseline. Here's two dudes measuring the same star from thousands of miles apart. And they're on a flat baseline, Dave. That's a flat earth. This isn't curving, my friend. So long as every example moving forward acknowledges the fact that we need a flat earth to get these angles, yeah, it's far easier to ignore that and start with them, isn't it, Dave? But to measure them, you need a flat earth, like you pointed out in your comment. That's gold.
Line where those lines intersect, which forms two right-angled triangles.
Not on a sphere, my friend. You don't get those 90s on a sphere. So you're annihilating a globe because you don't have 90 on a sphere ever. Maybe you didn't listen to my most recent video taking apart some bullshitter of a geodesic surveyor where it's talking about having straight lines and 90s on a sphere. These don't exist on a sphere ever. Why are you talking about 90s when you can't have them on a sphere? This is slightly bewildering to me. Anybody maybe care to posit an answer as to why Dave would be talking about 90s when they don't exist on a sphere?
This is why they said, shh, don't talk about 90.
Yeah, Dave wasn't around back then. Dave was just an itch in his dad's flat earth pants at that point, wasn't he? Because he wasn't around when they were all saying, shh, don't mention 90. Is Dave, old as you like, talking about 90? Dave, my friend, you need to keep up to date because this is devastating for you. What's this? This looks very much like a triangle, doesn't it? Yeah, this would be your dude taking an angle measurement to the star. I don't seem to see any assertion of height on here. Where does it show you the height? Oh, it doesn't. Oh, it's because it's not relevant, Dave, you stupid straw-manning idiot.
Go to the previous slide prior to that from the Smithsonian magazine.
You want to read it out? Go ahead.
Sure. A sextant is used to measure the altitude of a celestial body above a horizontal line of reference. Altitude in this case is a special use of the word describing an angular measure, not distance in feet above sea level.
Do you understand that, Dave? No, you don't. You're Dunning-Kruger. Yeah, did a little bit of research and started telling us about 90 and flat baselines. Meanwhile, this is a measurement that you can take, and it requires 90. Do you remember you telling us about 90, Dave? Yeah, devastating, mate, because you can't have that on a sphere. Now, in this depiction, they seem to have this curve to imply that the surface of the ground is curving. Yeah, that wouldn't give you this. See how it's labelled 90? That means this is flat. Like you described, Dave, remember, with the flat baseline? That's an actual measurement that you take in reference to the ground that you're standing on.
Being flat gives us a perfectly straight baseline.
Ground position, GP? Yeah, son. Yeah, it's in reference to the ground. Because you're describing 90 degrees too, aren't you? It's just you haven't tried to beat around the bush and make it look like we've got a curved surface. You're just balls out saying it's flat, aren't you, Dave?
Being flat gives us a perfectly straight baseline.
Yeah, no attempt to make this look like it's the curved earth. When you measure angles, it needs to be flat, doesn't it, Dave? To get this 90. Yeah, shocking. That's our argument, you know, Dave. If you weren't so stupid, you'd have realised that before you started reiterating this. Because this will also get trimmed out, Dave. It's very useful for our argument, these 90s. Yeah? Because they're on the surface of Earth. And you can't have them on a curve.
That's an official diagram where they try to curve the baseline slightly, right? Because of cognitive dissonance or whatever, right? But they can't be because it's using 90s. But when Dave tries to put a line through a sphere, then he'll be working outside of what this diagram, which is an official diagram, is claiming.
They need to infer that there's some sort of curve to the ground. That's why you end up with a diagram like this. They know that, oh, yeah, this is a bit awkward, isn't it? The ground's supposed to be curving and that. And we're talking about the ground position of the star with 90 at the ground position. At 90, meaning that it's flat. Yeah, so we'll obviously, we'll try and kind of allude to the surface being curved. You see that? Yeah, we'll make it look kind of like it's curving. We'll put a 90 on it, and we won't put it with a box. We'll put it with a curve. But it's still 90.
There's actually 2 90s.
One at the GP, one at the observer. You've got a square, basically, to the ground position. Now, like I say, these people aren't amateur Dunning-Kruger idiots, and they're trying to allude to there being a curved surface. There isn't. There wouldn't be 90 if it was. But like I say, Dave's just put it flat. Made it really clear that 90 meets a flat surface. Right, Dave?
Being flat gives us a perfectly straight baseline.
Bloody idiot. What an amateur.
It becomes even simpler if you're already dealing with a right angle straight out of the gate.
Because you'll have already proven a flat Earth at that point.
And we can use this to measure the size or the distance of things.
So you're saying if you've got a flat baseline and 90 degree along the surface from your position to the GP of a star, you can measure distances, to the GP? Yeah, you can, with the angle, not with the height, though. I mean, you just don't understand any of this stuff. You're stupid.
For example, let's say I want to know how tall this bottle is with...
Why? We're talking about celestial navigation. I mean, you seem to be all smarty pants when you were referring to one deck about celestial navigation specifically. Oh, yeah, with baselines and 90s and stuff.
Being flat gives us a perfectly straight baseline.
Yeah, like in this diagram. But now we're not going to be talking about stars. We're going to be talking about measuring physical items. Now, that's not what we do with celestial navigation, though, is it? He's drawing lines, calling them elevation angles, and they're meeting a curve. I can see it on screen. I mean, I couldn't, but I can now. There is no chord through this, Brian. That's a curve. That's a straight line.
He had a diagram where he put a chord through it.
He did, but he hasn't on this because he's stupid. So he's described, and I'll rewind it and play it again, elevation angle measurements. Then he's shown this. But as you can see on screen now, this line is meeting a curve. This is not an elevation angle, as described by Dave Keegan.
You have an object that is thousands of times further away than the distance between the observation points because the difference in elevation angles...
Difference in elevation angles. These aren't them, Dave. You can't get an elevation angle measurement from a curved baseline. We ask it daily. It's a housekeeping question, shit for brains. The difference in elevation angles... Oh, really? Is that what is on screen right now, Dave? It isn't, stupid idiot. Because that's a curved baseline. Hello? You've gone through what elevation angles are? Why would you show it with a curved baseline? Are you thick? Yes, you are. Is this me hand-waving you, by the way, Dave? Me showing your own stupid shit for brains diagram and pointing out that with on screen your words of the difference in elevation angles. These aren't elevation angles, you stupid idiot. Yeah, angle would be this, meeting a flat baseline, like a perfect flat baseline like you described. Yeah, hello, Dave Shit for Brains McKeegan. Anybody home? The flat baseline, do you remember? Yeah.
Everybody else is saying, shh, don't say 90, but he's saying 90. Brilliant.
It is.
There's a picture of it in Master D.
Maybe McKeegan's tactic is to, if he just debunks his own position within the argument before the opponent does, then he wins.
It seems legit.
Okay, yeah, I'll put this on if you like, 10th. It's on screen now.
Yeah, there's a picture, side-on view in a cartoon form of, there's what John was saying, you need a flat baseline to get that lighthouse, a known distance. So you already know what the lighthouse height is because it's on the charts, and you want to make sure that part between you and that cliff, if there's any danger angles there that you could avoid so you don't crash on the rocks. But you already know the height of the lighthouse, the height of the cliff, because it's on your chart written down.
That's fine, but even in this,
the ocean.
Okay, even in this example, you've got 28 degrees off a flat baseline. So according to this diagram,
Yes.
you've got 90 degrees to the lighthouse, 28 degrees from your position. This is a flat Earth proof as well. Dave McKeegan's example on screen now. 90 degree to a flat baseline.
Yeah.
It's a flat Earth proof. Can't be done any
And
other
don't
way.
forget, hang on. Don't forget the other picture showing a circle of equal altitude next to it.
That's what I was getting ready to say. If you use two flat Earth proofs in conjunction, that makes a globe, right?
No.
Oh, damn. Never mind.
We can measure the ground distance between the center of the base of the bottle and our observation point, which in the case of this is 40 centimeters.
On a flat table. So you're proving Earth's flat. So how we do it is use things that are flat to get 90 to them. Well done, Dave McKeegan. I'll say it again. You've proven a flat Earth. Yeah, flat baseline, 90 degrees. This is the methodology. Comparable to a table, scaled up, Earth's flat. Yeah, completely agree. All of the people around you, Dave, have been saying, don't mention 90. That's your side making it clear amongst yourselves on the globe side that you don't want to discuss the 90 degrees to the baseline with the star above it. Because that is only possible on a flat plane. Scaled up, it looks like this. That's a flat Earth, my friend. Is he insane? Did he go, oh my God, I chopped my head off. Quick, pour some acid on it.
Yeah, it seems that's what he's doing. He's going to really, 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 really prove it's flat this time.
And the table being flat gives us a perfectly straight baseline.
I cannot quite believe my ears. Sorry, chat commenter. Was this Dave annihilating me? Really? Let's have a listen to that again. I mean, this is devastating. You're absolutely right, chat commenter. I should have been so fearful of this video. Proving it.
It cannot be real.
No. This is Dunning-Kruger. I've never seen such a perfect example of it.
This is insane, is what it
The
is.
distance of things. For example, let's say I want to know how tall this bottle is without physically measuring it.
You'll need a flat Earth for that, Dave. Let's see how.
Well, we know if we put this on a table, the center of the top is going to be directly above the center of the base, and that's going to create a 90-degree angle to the table. We can measure the ground distance between the center of the base of the bottle and our observation point, which in the case of this is 40 centimeters, and the table being flat gives us a perfectly straight baseline.
Well done, Dave Triangles McKeegan. You have cemented your place in history as the first glober to go out of his way to make it absolutely 100% clear that the ground distance is flat. My God, I cannot quite believe it. I'm going to listen to that again.
Angle to the table. We can measure the ground distance between the center of the base of the bottle and our observation point.
So the ground distance, the distance along the ground. Gotcha.
Which in the case of this is...
This is not a category error when he compared it to the lighthouse. This is how you would get the height of the lighthouse on a flat Earth.
On a flat Earth, that's correct. Like Al-Biruni getting the height of the mountain. On a flat Earth. That's right. Dave McKeegan is currently giving my audience a jolly good flat Earth demonstration. That's right. Let's continue.
Yeah, if 1 second. If the lighthouse was 15 miles away from a boat, that would mean that the water between the boat and the lighthouse has to be horizontal for Dave's current description of a different use of triangles, as well as the other one.
Yeah, we're still on the straw man. He's not talking about celestial navigation anymore. He thinks, but by negating away from celestial navigation, not playing back his own comment about celestial navigation, he can talk about measuring angles to get height, which isn't celestial navigation. Yeah, he's a thicko. But in so doing, he's still proving that this unequivocally requires a flat Earth. He's just talked about the ground distance. Let's listen to the rest of what he says about the ground distance.
It's 40 centimeters. And the table being flat...
So when we're talking about ground distance, we're talking about it being flat. Well done. Welcome to Flat Earth. You're an idiot.
Gives us
well, technically, we don't even need, just very quickly, technically, we don't even need elevation angles because we can just use the angular sizes of things to get its horizontal distance. perfect example David's giving. If we use a lighthouse from 15 miles away, that will mean the water between the boat and the lighthouse must be horizontal, because you have to take in the height of the base of the lighthouse above sea level as part of your calculation.
Oh, like a really good flat earther, he's actually contributed to the argument. So where we have overcomplicated it until now, what we really needed was the insight of a Dunning-Kruger baller to simplify it not to celestial navigation and the complexities of acquiring areas of equal elevation, for example, but simple angular size measurement itself. In this case, the angular size of a lighthouse also requires a flat earth and is far simpler to describe, like Dave Triangles McKeegan is doing and proving a flat earth for my audience right now. It's really simple. You just compare measuring the height of a bottle along a flat table with an angle that requires the table as a prerequisite is flat, and comparable to the ground distance that's flat. Well done, Dave. Welcome to the club. That's right, Earth's flat. A simple height measurement of a bottle compared to the scale of Earth doing the exact same thing shows you that, like the table, it needs to be flat. Earth is flat.
Straight baseline.
It's worse than that, and I'll tell you why. Because he's also using perspective, which is what the angular size of something is. That's not part of the globe. Nah, there's no perspective. That's hijacked by the globe. He's debunking the globe and proving it's flat.
Would it get smaller? Eventually disappear? Because that's not in your Earth curve maths. You see, what I'd like to know, Dave, given that you're talking all about how high things are with an angle, where that appears in your Earth curve maths. Maybe, rather than telling your audience that I hand-wave your arguments, answer me that. Where is this example of angular relationships to things like a bottle represented in Earth curve maths? Feet and inches values don't change with distance. Their angular size stays the same at all distances, meaning this example isn't relevant to your globe model, because I don't know of any other globe model being claimed, and it definitely doesn't have this example of angular relationships to heights of bottles. So I'm a bit confused. Maybe you can tell us this straw man that you're burning is a very real problem for your globe maths because it's not appearing in them.
What globe maths?
Begging the question, proof of nothing. Perspective hijacking. Earth curve mathematics. The closest thing they've got to a model.
Well, no, that requires a flat Earth as well. That won't be globe mathematics.
You'll need a flat Earth for that, Dave. Let's see how.
Well, we know if we put this on a table, the center of the top is going to be directly above the center of the base, and that's going to create a 90-degree angle to the table. We can measure the ground distance between the center of the base of the bottle and our observation point, which in the case of this is 40 centimeters, and the table being flat gives us a perfectly straight baseline.
Well done, Dave Triangles McKeegan.